Hello everyone, now let's see how you can implement binary search in Python using recursion. The first thing that we have to do is to define a function in case we want to reuse the algorithm several times. We will name it binary search. Now the algorithm, since we are implementing it using recursion, is going to take 4 values, okay? First, it has to know what data it's going to analyze. In what data we're going to try to find that item. Then we have to specify the lower bound, then the upper bound, which we are calling high, and then we also need to pass in the item that we are trying to find. So we have 4 elements: data, the lower bound, the upper bound, and then the item that we are trying to find. You can define these in any order that you would like. Okay? It's just important to have these 4 in the parameters list. Then how do we implement the algorithm? We start by checking if the interval is valid. For that, we check if the lower bound is less than or equal to the upper bound. That is the only way that we can have a valid interval. Okay, so after we write this conditional, we have to find the middle index. Okay, so we define a variable, middle. And then to find that middle index, we add the lower bound plus the upper bound, and then we divide that by 2 using floor division. Like this. So we can see the priority of the operations. Then, after we have that middle index, what are we going to do? We're going to check if the element at that middle index is the element that we are looking for. So let's do that. If the element in the sequence in the data at that middle index is equal to the item that we are looking for, then we just have to return the middle index. We just have to return that index because we found the element that we are looking for. Else, if that is not the case, then we have to continue searching. And how do we do that? Let's see. We add an elif clause, because we want to know if we have to continue searching in the lower half of the list or in the upper half of the list. In this case, let's see if we have to continue our search in the lower half of the list by checking if the item that we are looking for is less than the middle element. If it's smaller than the middle element, then we have to continue our search in the lower half of the list, where all the elements that are smaller than the middle element are located. In this case, since we are going to work with recursion, we will have to write this return statement. Return the result of calling binary search or of performing binary search on the lower half of the list. We specify the same sequence because we are not modifying the sequence in any way. We are just changing the intervals in which we are looking for the element. We are going to keep the lower bound because we are going to continue searching from the lower bound, the previous lower bound, but now we are going to change the upper bound. And how do we do that? We are going to pass as the argument the middle index minus 1. So we are shortening the interval from the lower bound to the upper bound. And finally, we have to specify the item that we are trying to find. That item is always the same. That is in the case where we need to continue our search in the lower part of the list. But if we have to continue searching in the upper half of the list, because the item is greater than the middle element, then we have to write another return statement. And for that, we call the function binary search. Now we pass the sequence intact again, but we are going to change the lower bound this time. And how are we going to change that? We are going to move it further to the right. We are going to set the middle index plus 1 as the lower bound. Because we have to continue our search in the upper half of the list, we have to move the lower bound to the right. And we keep the upper bound intact, the previous upper bound. We pass the item intact as well, because that item will not change during the execution of the algorithm. It will not change at all. Now we have our 2 recursive calls, and we also have our base case, which is going to return the middle index, the index where the element is found if the element is found. And finally, we have to handle the case where the item that we are trying to find is actually not in the sequence. We cannot know that in advance, so we have to consider that in the algorithm, in the implementation of the algorithm. If the element is not in the list, then the recursive process is going to continue until it reaches a point where the interval is no longer valid. where the lower bound is no longer less than or equal to the upper bound. And how do we handle that? We add an else clause. If the interval is not valid, then we just return -1. And that is the basic implementation, the recursive implementation of this algorithm in Python. Let's test this to see how it works on a specific piece of data. Let's define a list of numbers. Let's call it numbers, and we just write an ordered sequence of items. 26, 38, 47, 136. We have some numbers, and we want to try to find a specific number in that sequence. Well, we are going to print the result of calling binary search on that sequence, the list, nums, and then we have to specify the lower bound, the upper bound, and the item, the 3 parameters that we have right here. The lower bound, where we are going to start the search, is going to be 0, because we want to start at the first index, at the first element in the sequence. And the interval is going to extend to the last index in the sequence. So that is going to be the length of the sequence -1. Because it is inclusive. When we use this formula, we are assuming that we are receiving the length of the sequence -1. And then finally, we have to specify the item that we want to find. In this case, let's say that we want to find 136. Right. Let's click this button and see how it works. And right here we can see the output, 7. Why did we get 7? Let's see. That should be the index where the element that we are trying to find is located in the sequence. We are trying to find the number 136. The result is 7, so it should be at index 7. 0, 1, 2, 3, 4, 5, 6, and 7. Yes, we got that number from the algorithm. And that is basically how we can implement binary search in Python recursively. I hope you liked this video, and feel free to watch it again if you need to review some of the details. If you like this video, subscribe to my channel and check out my other videos linked right here. I'll see you there.